welcome back to an overview of what's in Math64, the 7th release. So I posted this on the forum yesterday. It's pretty heavy on the output of the app actually, so if you haven't been running the test, you probably don't understand what's being displayed, which is okay, fair enough. So here I'm just saying we're touching base. As we made some more progress, and this time we're adding vector 3 support. So below is this dump. So we've got the test code in this section here. Starts with sort of vector 2 operations, very simple stuff, just adding things and some functions that are built in. At the moment we've only got really 4 functions for vector 2, 4 functions for vector 3, and those things are, you can grab the normal, you can grab the length of the vector, you can go to dot product and a cross product. Now, a cross product's not really possible. I'm not quite sure how you would define it in 2D, but there's a version there anyway. Beyond this, we've got vector 3. Oh, sorry, here's some usage of those things there. So the functions are, get normal 2D for a 2D vector, and it'll actually accept a vector or a variable, and if it's given a variable, it will use that variable and the variable after it as the X and Y field. So just be aware of that. That won't error. Well, it might error because the phrase is pretty dodgy at this point. We've got test and vector 3, so we've got a variable called dot product 3, which is our answer for that. 4 vectors of vector 3, position 3, speed 3, cross 3, normal 3. We're filling out our position 3 vector, the fields X, Y, Z. Filling out our speed vector, we're doing an addition of speed to position, a multiplication of speed on position. We're dividing it by speed again and subtracting it back. So eventually we get back to its original state. But it's just good to have those basic operations up and running. We've got a size computation from the position vector. Just you've got to be careful there too. I mean, it is computing a square root, but these days the performance of the FPU and square roots is pretty high, so you can do millions of square roots. Hate to tell you. Dot product as well. So I've got the dot product returning into a variable, so I can check its output later on. Got a cross for the same reason between the two 3D vectors, and the normal from the position vector here. So that's our example program. We can look at the code itself. Thinking here it is. Vector examples, yeah. Probably a bit easier to see on screen. Hopefully that's the same version of the code you're looking at that's stored in the archive. Looks to be, I think. At the moment we're not doing anything useful, are we? We've just got some very simple phrasing, very simple assignment type stuff, and life is kind of pretty simple, really. Performance wise it's running pretty well. If we go back to the forum, in this debug output here, we've got a list of the variable table internally. For what it matters, I guess, you've got the normal float variables here, which were declared early on, A, B, C, D, E, a size of float, a position 2D vector, a speed 2D vector, the speed thing called speed normal 2D vector. Then we have a temp, which is actually used in the expression evaluation. So these things fill up space in the variable heap. So you've got to be careful that if we have declarations like this, if you want all of your declarations to be side by side, they would need to be declared side by side. So what this means is that if you declare variables, have expressions in the middle of them, and declare more variables, you may well get temp variables generated on the variable stack. So if you want them to all be consecutive, you have to put all your declarations at the top of your program and then have your code below that. Pretty much like old C programs require you to do. It's not the end of the world, but you know, it's just the way it is. Back to here, so this is our declaration stack. We've got our stack size is 32 double longs pretty much, which is they're 8 bytes each. The bytecode represents our program is getting more complicated. We've got just our move operations, which is the normal stuff. Then our vector operations here with our copy of the result from the temp into the output. They'll be cleaned up in sort of the next couple of builds when we sort of work out what functionality we actually need in this thing. The bottom here, so vector 2 has its own command set, vector 3 has its own command set. Now they'll be called pretty much the same things for trying to make it consistent, which is always a problem. What I mean is the name's consistent, by the way. So you've got, if you call get .product 3D and you give it a 2D vector, it will just use the 2D vector plus whatever data is after it as if it was a 3D vector. It has no way of matching the data types in these functions. So it's a bit like the Wild West, actually. You know, we'll see how it goes. Maybe we might need better matching later on. Here we've got the results of expression table, the last expression that was processed by the Fraser, which just has a single result in it, which is good, because there's no syntax errors that occur within an expression. A bit of a test of execution. We've got 252 ticks for 1 million executions of that bytecode. All of this blob up here, all of this. And remember that things like get the normal have square roots in them. So we've got reasonable performance. We've got 252 ticks for 1 million executions of 47 instructions. That's about 180 million instructions per second. Pretty good. That's about all I wanted to show you, really. It's just what we're up to at the moment. And basically, if you have any ideas for what functions should be included, you know, if you could just, you know, knock up a version of the function or mock it up pretty much in just normal PBAM, or just implement it the way you imagine it, rather than me have to sort of have a circular conversation. You know, just do it, and if it fits into what we have, great, we'll just chuck it in. I suspect most of these things will just get chucked in anyway. But given it's pretty simple at the moment, we shouldn't be really having a massive impact on its performance. Anyway, thanks for watching, and have a bit of fun with it, and hope Christmas goes pretty well for you. And if I don't see you before then, or talk to you before then have a good one. Have fun and enjoy yourself over the Christmas break and New Year's break, and I'm sure we'll do something for New Year's. We've always been doing it lately. Anyway, thanks and bye.